Hello everyone, welcome once again to this online physics class. Again, we are continuing with the revision of this chapter, that is motion. In the previous class, we have revised the definitions, graphical patterns, scalar and vector quantities pertaining to this lesson. In today's session, we'll be revising the question answers. See, the first question is given here. An object has moved through a distance. Can it have zero displacement? What is distance and what is displacement? Distance is the actual path covered by an object, and displacement is the shortest distance between the initial and final points. The question given here is, if the object has moved through a certain distance, is it possible for the object to have a zero displacement at any point of time, right? So displacement can be zero. When can it be zero? When the starting and ending points remain the same, the displacement is said to be zero. When will you say a body is in uniform acceleration or non-uniform acceleration? Here you have to recall the definition that you have learned for uniform acceleration and non-uniform acceleration. A body is in uniform acceleration when the velocity changes in equal amounts in equal interval of time. Example, an object falling freely towards the ground. Non-uniform acceleration when the velocity changes in unequal amounts in equal interval of time. For example, a car moving in a crowded street. These can be given as in examples. But just you have to write the definition for uniform acceleration and non-uniform acceleration. Next question. What does the path of the object look like when it is in uniform motion? When the object is showing uniform motion, what does the path of the object look like? See, the path of the object can have any shape. For example, it can be a straight line, it can be in a curved path, it can be a circular path, it can even be a zigzag path. So when the object is showing uniform motion, the path of the object does not have any specific shape. It can have uniform motion in any shape. Okay, because uniform motion is what? When an object covers equal distance in equal interval of time. So there the shape of the path doesn't matter at all. Okay, now next question. Under what condition is the magnitude of average velocity of an object equal to its average speed? Again, I'm repeating the question. Under what condition is the magnitude of average velocity of an object equal to its average speed? The magnitude of average velocity of an object is equal to its average speed only when the object moves along a straight line path. So the average velocity, the magnitude of average velocity of an object is equal to its average speed only when the object is moving along a straight line. Clear to you? Question. Distinguish between speed and velocity. See, speed of a body is the distance travelled by it per unit time. So distance travelled by a body in unit time is what is called as your speed. Velocity of a body is the distance travelled by it per unit time in a given direction, because speed in a particular direction is called velocity. So this is your first point. Second, when you are talking about speed, the direction of motion of the object is not specified, but when you are talking about velocity, the direction of the motion of the body is specified. Okay, then speed has only magnitude, therefore it is a scalar quantity. Velocity has both magnitude and direction, therefore it is a vector quantity. So these answers are already there in the notes given to you. Please take off those and then you start revising again. Next, what is the nature of the distance time graph for uniform motion and non-uniform motion of an object? This was done in the last class also. I have already told you, when you are talking about distance time graph, always you have to take distance on the y-axis and time on the x-axis. When you are talking about uniform motion, the object is having uniform motion means the distance time graph will show a straight line, right? When the object is showing non-uniform motion, the object, again I'm telling you, distance is taken on the y-axis and time is always taken on the x-axis. So when you are talking about non-uniform motion, the object is showing non-uniform motion means it will be a curved line. It won't get a straight line pattern. Unequal distance covered in equal interval of time. Clear to you? The next question now. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? So again, a distance time graph. Time is taken on the x-axis and distance on the y-axis. So it says the distance time graph shows a straight line parallel to the time axis. If it is a straight line parallel to the time axis, what can you say about the motion of an object? So the object is not covering any distance. There is no change in distance. Time keeps changing, right? See, the time factor changes everywhere, whereas the distance point remains the same. This says the object is stationary or it is not showing any motion at all. Clear? Next is, what can you say about the motion of an object whose speed time graph is a straight line parallel to the time axis? Speed time graph, right? So when you're talking about speed time graph, a line parallel to the time axis, right? Like this. So this is your speed. If the object is showing a line parallel to the time axis, then the speed of the object at every instant of time is just the same. So the object is moving with a constant speed, or you can say the object is not showing any acceleration at all. So when you find a straight line parallel to the time axis on a speed time graph, you can say the object is moving with a constant speed. Clear to you? Which of the following is true for displacement? The given statements are: it cannot be zero, its magnitude is greater than the distance travelled by the object. While doing the first question itself, we saw displacement can be zero when the starting and ending point remains the same. So displacement cannot be zero is a false statement. Then its magnitude is greater than the distance travelled by the object. Remember one thing, the magnitude of displacement of an object can never be greater than the distance travelled by the object. So this statement is also not true. Clear to you? Next question. What does the odometer of an automobile measure? What does the odometer of an automobile measure? The odometer of an automobile measures the distance travelled by the vehicle. In your 7th standard itself, you must have learnt about speedometer, odometer and all. Clear to you? So with this, we are coming to an end of today's session. So I'll take up all the questions related to this chapter from your textbook and I'll be discussing the answers, and it will be a kind of revision to you also. Now for the upcoming test, you have only one chapter, that is gravitation. So please start learning that chapter. We have done enough revision for gravitation chapter, so I've started revising from the first chapter. Okay, so with this we are ending today's session. Meet you soon in the next class. Till then, take care, bye, and please solve the assignments that are uploaded in the Google Classroom and submit it on the date that is mentioned there. Clear to you? Thank you. Have a great day. Bye.